There's a funny thing about us humans. We spend a lot of time looking up. We stare at the stars. We dream of Mars. We send fancy telescopes into the blackness to peek at galaxies we'll never visit. It's a noble pursuit, no doubt about it. But while we've been aiming our rockets at the sky, we've mostly ignored the biggest, darkest, and arguably most alien world on our own planet. I'm talking about what's under the water. Not the sunny part where you go snorkeling, but the deep, dark, crushing blackness at the very bottom. It's a place so hostile, so foreign, that going there is in many ways harder than going into space. It's easy to forget that over 70% of our world is covered by ocean. And of that massive amount of water, most of it is a complete and total mystery. We have better maps of the moon and Mars than we do of our own seafloor. Think about that for a second. We've sent rovers to another planet, but we haven't even finished charting the ground we're standing on, just a few miles beneath the waves. It's a classic case of looking so far away that we miss what's right under our noses. It's just a testament to how unbelievably difficult the job is. This brings us to the fundamental itch, the one that drives explorers, scientists, and maybe even guys like me who are just professionally curious. It's the desire to know what's there. What's living in a place with no sunlight, freezing temperatures, and pressure that could turn a pickup truck into a pancake? So, where is this place? If you want to find the absolute bottom of the world, head to the middle of the Pacific Ocean. Way out there, east of the Philippines, south of Japan. You'll find a massive, crescent-shaped scar in the Earth's crust. This is the Mariana Trench. It's a subduction zone, one tectonic plate getting shoved beneath another. Think of it as a geologic fender bender in super slow motion. Over millions of years it created the deepest canyon on the planet. Inside that trench is a specific spot, a small basin that holds the record. It's called Challenger Deep, named after the HMS Challenger, a British survey ship from the 1870s. They didn't know it was the deepest then, but they knew it was ridiculously deep. How deep? The bottom of Challenger Deep is almost 11,000 meters, about 36,000 feet. That's nearly 7 miles. Imagine taking Mount Everest, the tallest mountain on Earth, dropping it into Challenger Deep. Its peak would still be more than a mile underwater. Stack 2.5 Grand Canyons one on top of another, and you still wouldn't reach the surface. At the surface of the ocean you have 1 atmosphere of pressure. At the bottom of Challenger Deep you have over 1,000 times that. It's like having 50 jumbo jets stacked on you. Pressure so immense it can change molecular structure. This isn't just a hole, it's a different world with different rules. Zero sunlight, not a single photon reaches this far. Water temperature just a few degrees above freezing. Eternal darkness and cold, under a weight that defies imagination. So how do you visit a place that's designed to crush you? You don't just slap on some scuba gear and hope for the better. You need a machine, a very special kind of submarine called a submersible. These aren't the big, long submarines you see in war movies. Think of them more like a high-tech elevator or a tiny spherical spaceship designed to travel down instead of up. The most important part is the pilot's sphere. A small, perfectly round ball made of incredibly thick metal, often titanium. Why a sphere? Because it resists pressure from all sides. Any flat surface or weak point would buckle instantly under the immense force. Inside this titanium bubble, several inches thick, the pilot sits in a space about the size of a small closet. Surrounded by life support systems, navigation controls, scientific instruments, the pressure inside stays at 1 atmosphere, the same as the surface. A tiny pocket of Earth's environment, a fragile bubble of safety carried down into a world that wants to pop it. Getting down there is a slow, careful process. The submersible is essentially a high-tech rock. It's loaded with heavy steel weights that pull it downward. The descent can take hours, a silent fall through miles of water. The pilot watches the depth gauge tick down, meter by meter. Outside the portholes, blue, deep blue-gray, absolute, impenetrable black. They're completely alone, a single point of light and life in a vast, hostile universe. For the longest time, the smart money was on Challenger Deep being a dead zone. The logic was simple. No sunlight, no plants, no food. Add in the crushing pressure and freezing cold, and it seemed impossible for anything to survive. But in 1960, when Don Walsh and Jacques Piccard made the first ever dive in the bathyscaphe Trieste, they looked out their window and saw something that changed biology forever. They saw a flatfish, a type of sole, swimming calmly along the bottom. Life. It was there. The abyss was not dead. Since that first dive, every expedition has returned with evidence of a surprisingly busy ecosystem. You won't find giant sea monsters with glowing teeth, at least not yet. The life here is more subtle, and in many ways more bizarre. One of the most common residents is a creature called the Mariana snailfish. It doesn't look like much. It's a small, pinkish-white, tadpole-looking thing. But this fish is a marvel of evolution. It's squishy and gelatinous with no scales and a flexible skull allowing it to withstand pressures that would pulverize a normal fish. It's the king of its castle, the deepest living fish ever discovered. For all the amazing things we've found in Challenger Deep, the most exciting part is honestly what we haven't found yet. The truth is, our explorations have been like taking a few snapshots of a continent at night with a weak flashlight. We've only visited a handful of spots on the seafloor and just for a few hours at a time. The total area we've actually seen with our own eyes is probably smaller than a small town. The vast majority of the Mariana Trench and the deep ocean remains completely unexplored. One big mystery is the trench's geology. We know it's a subduction zone, but what exactly happens down there? Could seawater reacting with rock under intense pressure cause strange chemistry? Some scientists propose serpentinization, where water reacts with mantle rock to produce hydrogen. If true, that hydrogen could be an energy source for life, independent of the sun. It could mean entire ecosystems fueled by the Earth itself. Then there's life. We found snailfish, we found amphipods. But what else is there? Might larger predators exist that we've never seen? Sailors' Kraken stories are fun, but reality could be stranger. Gigantism is real in the deep. Giant squid live in the twilight zone, which is far above Challenger Deep. Could even larger animals lurk in the abyss, slowly moving through the dark? We simply don't know. One of the most surprising discoveries about Challenger Deep has nothing to do with what you can see, but what you can hear. You would think that a place 7 miles under the ocean would be the quietest, most peaceful spot on Earth, a silent world of blackness and pressure. But when scientists lowered a special hydrophone, a titanium-encased microphone, down into the trench and left it for a few weeks, they were shocked by what they heard. The abyss, it turns out, is a noisy place. It's filled with a constant cacophony of strange sounds. The recordings captured a mysterious blend of noises from both natural and human sources. The scientists could clearly hear the calls of baleen whales and the clicks of dolphins, their sounds traveling for hundreds of miles and echoing down into the deep canyon. They also picked up the low, constant rumble of earthquakes from the tectonic plates grinding against each other. It's the sound of the planet itself, groaning and shifting. The trench acts like a giant echo chamber, trapping and amplifying sounds that might otherwise be lost in the vastness of the ocean. But it wasn't just natural sounds. The hydrophone also recorded the unmistakable thrum of ship propellers from vessels passing on the surface miles above. It was a sobering reminder that our noise pollution reaches even the most remote and seemingly pristine corners of the planet. What's truly baffling, though, are the sounds they can't identify. The recordings are full of strange moans, bangs, and metallic-sounding noises that don't match any known source, animal or mechanical. For now, they are just echoes from the abyss, a set of spooky, unanswered questions that make scientists more eager than ever to go back and listen more closely. When you go to the deepest place on Earth, you don't just take pictures, you bring back souvenirs. But these aren't your typical t-shirts or keychains. The most valuable thing you can collect from Challenger Deep is mud. It might not sound glamorous. The sediment on the seafloor is like a diary, a library of Earth's history written in layers of fine silt. Everything that has slowly drifted down from the surface over millions of years is preserved there, in chronological order, in the cold, dark, and undisturbed environment. Scientists use a tool called a core sampler, which is essentially a long, hollow tube that they push deep into the sea floor. When they pull it back up, it contains a perfect cross-section of the sediment, with the newest layers on top and the oldest layers at the bottom. By analyzing these layers, they can learn an incredible amount about the past. For example, a layer of volcanic ash could be matched to a specific eruption that happened thousands of years ago. A change in the types of microscopic shells could indicate a major shift in ocean temperature or chemistry. This mud, or more technically this ooze, is made up of the microscopic skeletons of plankton fine clay dust blown from continents and cosmic dust from space. It accumulates at an incredibly slow rate, maybe only a few millimeters every 1,000 years. This means a core sample that's just a few feet long can represent a huge slice of geological time. But the mud holds more than just history, it holds life. Within these sediments, scientists have found thriving communities of microbes, living fossils from an ancient world. It's a fair question to ask. Why spend millions of dollars and risk human lives? Go to the bottom of a cold, dark hole in the ocean? It's not like there's gold or oil down there. The value isn't in what we can take, it's in what we can learn. Exploration of extreme environments like Challenger Deep is a huge driver of technology and innovation. Building a vehicle to withstand that pressure forces us to create new materials, new life support systems, new ways of navigating and communicating in impossible conditions. These breakthroughs don't stay in the deep sea. Submersible hull design can mean stronger, lighter materials for aerospace and for construction. High-efficiency battery systems for a sub can lead to better batteries for electric cars and for home energy storage. Robotic arms and high-definition cameras from deep-sea work find new uses in remote surgery and in industrial inspection. Pushing the limits in one field often creates ripple effects we can't even predict. Beyond the tech, there's the biology. The creatures that live in the abyss have evolved unique biochemical tricks to survive. Their enzymes work under high pressure and low temperatures, useful for detergents, for cold water washing, useful for biotechnology. Some deep-sea organisms produce compounds that show promise as new antibiotics, or anti-cancer drugs. The deep ocean is a massive untapped genetic library. Maybe cures live in the cells of a simple snailfish, or in a mud-dwelling microbe, but maybe the most important reason is the simplest one. It's about understanding our own planet. The deep ocean plays a critical role in regulating our global climate. It absorbs a massive amount of heat and carbon dioxide from the atmosphere, acting as a buffer against climate change. The currents that circulate through the abyss help distribute heat around the globe. If we don't understand how the deepest parts of this system work, our climate models will always be incomplete. To take care of our planet, we first have to understand how all of its parts, especially the hidden ones, are connected. For all of human history, the deep ocean has been a symbol of the unknown, a place of myth and fear. But today, thanks to a handful of brave explorers and brilliant engineers, that is beginning to change. Challenger Deep is no longer just a theoretical point on a map. It's a real place that we can visit, study, begin to understand. We are peeling back the darkness, layer by layer, discovering that this extreme world is not dead and empty, dynamic, mysterious, full of life. It's a frontier in the truest sense of the word. The journey to the bottom of the sea is, in many ways, a mirror of the journey into outer space. Both require us to leave our comfortable world behind and to venture into a hostile environment in a fragile, life-sustaining capsule. Both push the boundaries of our technology and our courage. But there's one key difference. The deep ocean is part of our world. The greatest adventures aren't always out there among the stars. Sometimes they're right here at home, waiting for us at the bottom of the sea. And there's still a whole lot of bottom left to see.